So today we're going to talk about Pythagorean Theorem, and Pythagorean Theorem is considered by many the most elegant theorem there is in math. It is one that is not only awesome and does so much for it, but it's also simple. So you're going to like it. It's named after Pythagoras, and we could spend a whole day talking about Pythagoras, and is it really him that wrote the first theorem for it, for the first proof? But a lot of times theorems are named after whoever proved it. And there are so many people that proved Pythagorean Theorem. Even one of our U.S. presidents, President Garfield, back in 1881, he was the president. And when he was a congressman before that, he wrote a proof for Pythagorean Theorem. Einstein wrote a proof for Pythagorean Theorem. So a lot of people have done that. But he's the first one. And Pythagoras was back in the BC years. So we're talking 2,000, 3,000 years ago when he was first credited with this. So anyway, let's talk about what it is now. So it is only about right triangles. So Pythagorean theorem is only for right triangles. And in order to talk about that, first we need to know the parts of a triangle. And I want to talk each of the sides forming the right angle. So here is the right angle, and remember a right angle is 90 degrees. This is how we indicate a right angle, that little symbol right there. And the sides that form that are called the legs. And you have legs in triangles in both right triangles and isosceles triangles, but other triangles don't have that. But these are the legs of a right triangle. Now this other side, in a right triangle, the side opposite. In math, we do some weird things. Sides can actually be opposite of an angle. So this side is opposite that angle. And the side that is opposite the right angle is called the hypotenuse. Hypotenuse. Okay, isn't that a great word, hypotenuse? And this side right here is the hypotenuse. It will always be the longest side. And you'll learn more about that in geometry. We don't get to deal with it this year, but you'll learn that it has to be the longest side. You'll learn more about that. Now, Pythagorean theorem describes the relationship of the lengths of the sides of a right triangle. You can put any there, but just the sides of any right triangle. Okay? And it's talking about what is the relationship between them. So in any right triangle, and of course we always have to go to the mathematical stuff, then I'll show you a little bit more about what you're going to remember. In any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Okay, so here's our right triangle. And what this is saying, sum, remember, means add. So we're going to take the legs, but we're going to square them. We're going to square each of those legs. And what this is saying is that is equal to the hypotenuse squared. Well, you could see this would be a real pain to have to keep writing this out. So Pythagorean theorem, if you would walk up to anybody who's ever taken high school math, and if you say Pythagorean theorem, they would probably be able to tell you, and the way they remember it is a squared plus b squared is equal to c squared. So the legs are a and b, and it doesn't matter which one's a and which one's b. It honestly doesn't matter. So just name one of them a and one of them b. Now, the side opposite the 90 degree always has to be c. The hypotenuse is always c in this formula. Okay? And it's not really a formula, it's a theorem, is that the square of the lengths of, well, right here, this is our theorem. If you read through that, that's the theorem. In any right triangle, the sum of the squares of the lengths of the legs is equal to the sum of the length of the hypotenuse, the square of the hypotenuse, okay? So what this is so wonderful, the reason it's so awesome, is if you are given two sides, any two sides of a triangle, you can find the third side of a right triangle. Okay, so we're going to find that missing side is what we're going to do with it first. So here's my right angle, okay? So if that's my right angle, what is this? That's a leg, and this is also a leg. So this is A, and this is B, and this has to be C. Now, as I've said before, in order to learn something, a lot of times, every time we write it, it's gonna get etched in our brain a little bit more. So let's write that down. A squared plus B squared is equal to C squared. And you have to know that the legs, and it doesn't matter which leg is what. Could be A and this could be B. It does not matter. Okay, so plug it in, and I have 8 squared plus 13 squared is equal to C squared. Now, 8 squared we know is 64. Hopefully you remember that 13 squared is 169. We have C squared. Now we're going to pull out our calculator. And yes, this part of the test we get to use calculators. So we're going to add 64 plus 169 gives us an arrow if you do it the way I did it. Okay, how about if we hit plus instead? And we get 233. Okay, now we have to solve for C. We don't ever solve for C squared. So now we have to kind of think for a little bit. If I want to get rid of a C squared, what would be the opposite operation? Now I'm going to give you a hint because this is something you can always use to help you. If you look at your calculator, if you look at this calculator and pretty much any calculator, okay, see how there's an x squared right here? Look what's right above it, square root. These are opposite operations of each other, okay? So I'm going to write this out again, and I'll do this just one more time with notes, okay? And what you have to do is if I want to get C squared, if I want to solve for C, I have to take the square root, and whatever I do to one side, I have to do the other side. So I'm going to take the square root of both of these sides. So I'm going to get the square root of C squared is C. So here's one thing you might want to realize and write down, is this radical, a square root sign, and a squared number, it's like they cancel each other out, and they do cancel each other out. Okay, so the radical and the squared will cancel each other out. So if I ever take the square root of something squared, I'm just going to get that something. So here it's going to be C. Now, 233 is not a perfect square, in case you were wondering. So we're going to learn how to do it on our calculators. And you could just start over again and go square root, and that's just the second function. But I want to show you another key that I have found to be very helpful in my math career. Look right down here. See how that's a negative? That's not the helpful one. It's what's right above it where it says ANS. That stands for answer. It means the previous answer. And notice that's above it, so that means I'm going to use this second function up here. So watch what happens when I push it. So I'm going to go second function, and I'm going to go answer, and what it's going to do is it's going to pull the answer from right up there. Okay, now that's not too helpful as it is there, but watch what we're going to do. We want to take the square root of that, so we're going to hit second function, x squared, and see how that radical comes up. Now what do we want to go in it but this 233? So we want the answer. So we're going to go second function, answer, and see how it comes right in there? So when I hit enter, I get the square root of 33. Now that's not too helpful. We know that we're going to get a decimal because look at the directions. Round to the nearest tenth. So I have to get a decimal. So I learned another key. I've been wondering what this key does. If you push it, look what happens. We get a decimal. It tells us what the decimal equivalent or approximation, here's approximation, would be 15.264 blah 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 blah. So now I'm going to write that down. 15.264 blah blah blah. 15.264 blah blah blah. Now it wants us to round to the nearest tenth. What I think the easiest thing to do with rounding is you always underline where you want to round to. Look one behind it. 5 or above, give it a shove, meaning add one. 4 or below, let it go. Let it go. Okay, I won't sing to you. But I always underline where I'm rounding to. So this is 5 or above, so I'm going to give it a shove. So it's 15.3 is equal to C. Now, mathematically, we should actually say approximately equal to. Those are those little tilde signs. It looks like this. Okay, that's approximately equal to. But since they gave the directions to round, we can just say 15.3 is equal to C. Okay, we learned so much in just that one problem. Okay, now it says leave your answer in simplest radical form, and it gives us A and B. We could just plug it into the formula, but I want you to get used to drawing pictures, because we're going to be doing that here pretty soon. Now, name one of your legs A and one of them B. It doesn't matter. Okay, so I'm going to make that this is 10 and this is 12, just because I went left to right. This is C. That's what we have to find. So now, write down Pythagorean Theorem. A squared plus B squared is equal to C squared. And we're going to plug it in. So we have 10 squared plus 12 squared is equal to c squared. 10 squared is 100. 12 squared we all know is 144. Hopefully you're starting to get those perfect squares memorized. Okay, so now we're going to add those two together. We get 244 is equal to c squared. But notice it says simplest radical form. So we're not going to use our calculator this time. We're going to take the square root of both sides. Now, see, that's what I did there. I didn't write it out twice. I just went to taking the square root right there. We know this is c. 244. Do you know that one off the top of your head? No. I'm going to start off by using factor tree. And I'm going to take a 2 into it. Well, 2 goes into 2 once. 2 goes into 4 twice. So 2 goes into that 4 twice. Break that down by 2. 2 goes into 12, 6. 2 goes into 2, 1. And there's my pair. So I get 2 square root 61 is equal to c. Now the other way I could have done it is broken it into 4, and I have no clue. So 244 divided by, oh, well that's easy. 4 goes into 24, 6. 4 goes into 4, 1. That wouldn't have been so hard. Okay, so that's what it's equal to. Oh, wait, but it has a measurement on it, so 2 square root 61 inches. If we're going to put inches on it, we're going to probably put it as a decimal, an approximate decimal. Okay, number 3. Here we go. Here's my right angle. And notice I have a leg, but this time look what I have. I have a hypotenuse. So I am looking for an A or a B here. What do you want to name it? I'm going to go with A because my handwriting's bad and you can understand an A better. So we're going to go A squared plus B squared is equal to C squared. We plug it in. We have 10. Oh, no, we decided A we didn't know. A squared. We plug in 10 square root 3 squared. Now, on the last one, we wouldn't have had to put it in parentheses, but on this one, we need to put it in parentheses because we have a 10 and a square root 3. So let's look at that. What does that 10 square root 3 mean? What this means is use your power to a power. So I'm taking 10 to the second power, and I'm taking square root 3 to the second power. Well, we can use what we just learned, is that a radical and a square cancel each other out. Or we can also look at it. We could rewrite this to be the square root of 3 squared, which we know is 3. So we can put that squared either place. Even we can remember that a radical and a squared cancel each other out, or we can just square the 3. Then we have 10 squared, which is 100. So when we multiply those two, we get 300 right here. Oh, hey, look at this. I forgot to plug in C. C is 22. Okay, 22 squared. I'm going to use my calculator. Whoops. 22 squared. 484. Okay, now subtract 300. Okay, and what are we going to do now? If I want to find the square root of, if I want to find A, I just already told you, I take the square root of both sides. Now, mathematically, I need to tell you this just so I'm more comfortable. We are only taking the positive root. That doesn't mean anything to you right now, but it will eventually. And so we're just taking the positive root of these squares. So now 184. What method do you want to do? Simplify that. Go. I'm going to pause. You're going to simplify it. So if you did perfect square, non-perfect square, 4 goes into it 46 times. And then we take the square root of 4 and get 2. Or you could have done it by factor tree. Here's your pair, and the 42 spits out. Now, it does say feet on it, so let's make sure we always label it too. Good. Backside. Okay, now is when it gets even better. I know that this might be surprising, but word problems in Pythagorean Theorem are just like fun. They are just so cool. So, and you feel pretty smart after you do them, so it's pretty cool. When solving these problems, it may be helpful, not maybe, oh my gosh, it is helpful to draw a picture. And we're going to pretty much draw a triangle every single time. Okay? In real-world situations with Pythagorean theorems, answers should always be written, I would say usually be written in decimals, as decimals. Okay? And they're usually rounded to a nearest place. Okay. So here we go. Are you ready? This is when it gets fun. A cat was stuck in a tree. Okay. The tree was 15 feet tall and the ladder was 20 feet tall. Ladder was 20 feet tall. How far is the bottom of the tree away from the base? So, draw a tree. You'll see pretty soon why I'm a math teacher and not an art teacher. Here's my tree. Then goes to, let's see, the tree is 15 feet tall. So from here to here is 15. Then we have a ladder that is 20 feet tall. So what they're saying is we're going to lean the ladder up against the tree. So we're going to say this is 15 to where that ladder is going to go. And here's my ladder. Here's my ladder. So what's happening is this is the height, this is the ladder, and this is the, and we know this is 20 and this is 15. Well, that tree has to be assumed that it's a 90-degree angle. So that's my picture. Let's draw it out here though as a triangle. Okay? So this is 20, that's my ladder. Here's the height of my tree, and this is what I want to know, is how far is the bottom of the tree away from the base of the ladder. See that space right there? That's what we're finding out. Now look at that. Can't we just plug it into Pythagorean Theorem? Yes, we can. A squared plus B squared is equal to C squared. What is C here? That's right, it's 20. That's my C. Always identify your C because your legs, it doesn't matter which one's which. So plug in your C, okay, and then plug in 15 for one of them, and we have to solve for the other. 15 squared we know is 225. 20 squared is 400, because I take the 2 and square it, and I add 2 zeros on. See how 2 zeros? And I just square that front one. I subtract 225 from both sides. I get b squared is equal to a number. Once you know, that's the stuff I can't do. Okay, so 400 minus 225 is 175. Okay, now let's leave that on our calculator, because we're going to probably have to find that out. It does not tell us if we're going to round our answers and do it as a radical. So just pay attention to that. I think a lot of your homework, it will say, I'm going to look that up right now. In your homework, I believe it says to round it to the nearest tenth a lot of times. Round to the nearest tenth of a whatever on most of your homework. So, okay. So that means we're going to take the square root of both sides. So we're just going to plug it into our calculator. We already have it there. Let's use that funky stuff that we were doing before. So we're going to go second function square root, because we have to do that x squared. And then we want that in there, so second function answer. And we're going to hit equals, and it's going to give us 5 square root 7. Oh my gosh, your calculator even does that. So the square root, so this is 5 square root 7. Hey, that's handy to know. Okay, but we want the decimal of that, so we're going to hit this little button right down here. And it's going to give us 13.228, blah, 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 blah. Let's round it to the nearest tenth. So 13.22 blah, 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 blah. We don't need to know that. 5 or above, give it a shove. 4 below, let it go. So let's let it go. And what were our measurements? Feet. See, wasn't that fun? Word problems are not bad. It's just some of them are complicated. This is not one of them. Okay, the softball was thrown 20 yards east, then 40 yards north. What is the distance between the two throws? So this is where you kind of have to know your compass. So remember, north, south, east, and west. Okay, I always remembered it we, so west to east is we. Okay, so now let's draw this. The softball was thrown 20 yards east, and then 40 yards north. Okay, what is the distance between the two throws? And east and north are perpendicular. They form a 90-degree angle. So this is our C, right? So we don't know C. So A squared plus B squared is equal to C squared. Plug in. These are your legs. Just choose them and plug them in. 20 squared, remember, is 400. Because you square the 2 and then 2 zeros. Square the 4, 16, 2 zeros. Okay? Add those together, you get 2,000, I think. Yeah, I know. I can square things, but I can't add things. We get 2,000. And now, of course, we're going to take the square root. We have 2,000 in our calculator. Let's just take the square root of that. And I got 44.721 blah, blah, blah. So that'd be 44.7 yards. Okay? Oops, can't see the bottom. 44.7 yards. So you have worksheets that we want you to do. And we want you to do this one, the Pythagorean Theorem and its converse, the front and the back. And then you have a page of word problems. That is the other part of your assignment. So you're going to be working on this both Tuesday and Wednesday. And remember, Wednesday or help sessions, come in and see me. That's not a problem. And you can come in and get help on these. And I'm more than happy to help you on any of these problems. Draw a picture, draw a picture. Okay, good. Thank you. I know it's a long video, but it's worth it. So thank you.